Congratulations, you completed all the main lessons of the course. You explored what sequencing, exome sequencing, and whole genome sequencing are, and went through steps of a basic NGS data processing workflow, and then moved on to Parabricks. With Parabricks, you learned what Parabricks is, its advantages, its real world use cases, and its challenges. Then you implemented an accelerated workflow using Parabricks and gained hands-on experience. So during this course, you covered a large scope. Now you are ready to dive into bonus lesson and explore concepts like benchmarking, profiling, further optimization, and automation. So let's move into the bonus lesson. In this course, we mainly discussed Parabricks as a accelerated accelerated NGS processing solution. However, Parabricks is not the only player in the town. Another widely popular accelerated solution is called Dragon, which is offered by Illumina Technologies. Dragon uses a different hardware platform for acceleration. It is called Field Programmable Gate Arrays. The comparison between GPUs and FPGAs or Field Programmable Gate Arrays is beyond the scope of this course. However, if you are interested, I have provided additional resources in this lesson so that you can go and explore more. So when we are talking about accelerated NGS data processing, it is important to benchmark all the widely used accelerated platforms. In this case, the Parabricks and Dragon. So that's what we did in our benchmark study. We compared the CPU, we compared the NGS data processing on CPU platforms, GPU platforms, or Parabricks platforms, and Dragon. So in this first figure shows that when we run our samples on CPU platforms, a CPU only pipeline, the runtime is considerably larger than all the accelerated platforms. Meaning, when you implement any accelerated platforms, you could cut down the runtime drastically. If you are interested in reading or looking at the actual numbers, I encourage you to read our paper where we have provided a detailed information about these benchmark datasets. During the lessons, I briefly mentioned about the differences in mapping and variant calling accelerated speedups. That's what we are discussing in this section. Parabricks, I mentioned that it can be run on different GPUs. So we implemented Parabricks on GPUs on L4 GPU, A100 GPU, and H100 GPUs. And then we compared their performances to Dragon. This figure shows the speed up. The speed up is calculated using the CPU runtimes as the baseline. So this shows how many times mapping is the speed up factor of mapping compared to the CPU baseline. When we are comparing accelerated platforms, especially Parabricks on different GPUs and Dragon, we can see that Parabricks on H100 and Dragon are on par with regarding the speed up. However, with the variant calling, we could see that Parabricks acceleration is greater than the acceleration offered by Dragon. Again, in our study, we have provided more detailed figures and tables so that you can explore the actual speed up factors and the runtimes.